All right, looking at velocity graphs or velocity versus time graphs, there's a number of things that we can determine. First of all, because it's a velocity graph, the points don't tell us where an object is at, it tells us how fast it's going. It tells us the velocity. If we look at the slope of the graph, the slope is a measure, of course, of rise over run, and our rise is in meters per second, our run is in seconds. And so that's an acceleration, not a velocity. Okay, so you got to make sure you keep the type of graph straight as to what you've been given. The area would be found or would be calculated taking a rise value times a run value and then maybe a half or something like that, but the seconds part would cancel out and you would be left with just a value of meters. So the area gives us the displacement or how far an object has traveled, and that should be measured in meters in most cases. If we see a straight line like we see in the beginning here between 0 and 2 seconds of this graph, that straight line does not indicate a constant velocity. Because slope is acceleration, this is constant or uniform acceleration. So this means that the object is speeding up. The value of the velocity keeps on getting bigger and bigger, from 0 in this case up to 50 meters per second. If we do see a horizontal line like here, okay, that indicates that the velocity is steady. It's a constant velocity. Okay, so that's a little different. You got to be very aware of what type of graph you are looking at. Now, if you could possibly see a curve, but not in our class. Okay, so you will only see straight lines or horizontal lines on the velocity graphs at this point in your physics life. So how do we find values on this graph? So to find the displacement, we would look at the area, like was mentioned earlier. So for instance, if I wanted to find how far the object moved between 6 and 8 seconds, I would draw this rectangle. Notice how the top of the rectangle is the graph itself, and I'm using the time values to create the vertical parts. And then the bottom section here is the axis itself. So that's the axis, the time axis is going to form one side of your shape. And so in this case, I would look at the height. It looks like it's 30, but that's 30 meters per second. Notice I'm not just counting boxes. I am using the scale to help me out here. So 30 meters per second. And then along the time axis, it's from 6 to 8 seconds. So that's 2 seconds. And putting my units in really helps me recognize that this is a displacement, 60 meters. If I was going to look at a point that had, between 2 points where I had to worry about a triangle or a trapezoid or something, I'd have to use that shape. So let's say I was going from 3 to 6, and this was the shape I was looking for. I could use the area of a trapezoid, which is 1/2 base plus base, all times the height. So that would be 1/2 times, I'm going to leave my units out so I have room, but my base would be like, say, this. That's 10 meters per second. And then my other base would be this over here. That would be 30. And then my height of my trapezoid is along here. That's my 3 seconds. So I'd take 1/2 of 40, so that's 20 times 3. Again, 60 meters, okay? That doesn't always happen, but in this case, these two areas, my red area and my purple area, end up being the same size. All right, to find the velocity for a particular section, I'm just looking at a point. That's what points on this graph tell me. So if it said, what's the velocity at 11 seconds? Okay, so I would look here, and I would say that the velocity is -10 meters per second. So look at the point value on the graph. To find the acceleration, I would look at the slope. So let's go ahead and find the acceleration from t equals 2 to t equals 3 seconds. So the rise over run my rise is actually a drop. So it's going from 50 to 10. So that's a change of 10 minus 50. It's going to be negative meters per second. And then my run is just from 2 to 3. It's just 1 second. And so I have negative 40 meters per second over 1 second. So my acceleration is negative 40 meters per second. Again, my slope should tell me an acceleration.